This is Lesson 11 corresponding to Chapter 11, Part 1, VPN Management. The learning objective is to appraise the elements of VPN implementation and management. The key concepts are the best practices for implementing and managing VPNs, common network locations where VPNs are deployed, VPN deployment planning for the enterprise, the general nature and source of threats against VPNs, and VPN policy creation. VPN practices pre-deployment. Choose a solution that's right for your environment with proven capabilities. You might well be able to adapt a process from another company to fit your environment. Keep what works, modify what you can adapt, and ignore what doesn't make sense. Plan to provide redundancy. Often VPNs are provided by way of a cloud implementation. If so, be sure that a level of redundancy is built in and that the redundancy is clearly spelled out and guaranteed in the service level agreement. Create a written VPN policy. Ensure client security, including vulnerability management. Document your VPN implementation plan. You might want to keep a spare VPN product on your shelf, configured and ready to go live in the event of a failure. Developing a VPN policy. Restrict remote access to the organization's VPN solution. Prohibit split tunneling. Split tunneling is a configuration setting that allows simultaneous access to both an untrustworthy network like a home network and a secured VPN network connection. The reason split tunneling is a bad idea is that it potentially opens a door into your network that you cannot control, which is known as hairpinning, because malicious code can enter from the non-secure network, make a hairpin or sharp turn, and enter your secure network with little or no trouble because it is entering from a secure and verified endpoint. Define classes of employees that can access the network by VPN. Define types of VPN connections to permit. Define the authentication methods permitted. Prohibit sharing of VPN credentials. List the configuration requirements for remote hosts, including current virus protection, anti-malware, host-based intrusion detection systems, or HIDSs, and a personal firewall. Continued. Prohibit the use of non-company equipment, or if personal systems may connect to the VPN, define the minimum standards for those connections. These include personal devices, such as those allowed if your company has a BYOD policy. policy. How should such devices be admitted to the VPN, and what are the policy and technical guidelines for connection? Define the required encryption levels for VPN connections. If you'll be using your VPN for network-to-network connections, define approval process and criteria for establishing that network-to-network connection. These are three things you need to perform regularly when we talk about post-deployment of a VPN: a usage review, backing it up, and patching. Where you will deploy the VPN on your network. The next three slides describe three different architectures that typically accompany VPN solution deployments: bypass deployment, internally connected deployment, and DMZ-based deployment. Here is bypass VPN. You can see the VPN and the fire is connected to an internal network as well as a firewall. Firewall protects the internal network. You do this so that traffic to the VPN and from the VPN to the internal network is not firewalled in any way. The VPN is on the other side of here, you see, of the firewall. This was a common architecture when they were first introduced to the market. The logic behind this deployment architecture is that since the VPN will accept only encrypted connections on a specific port, the security is adequate without additional firewalling. Additional consideration is that since traffic is encrypted, it doesn't need additional protection. Even if you placed a firewall on the internet-facing VPN connection on the left-hand side over here, the firewall wouldn't be able to analyze the encrypted VPN traffic. There are two significant issues with this implementation model. The first is that VPNs are like any other network device. They can have a variety of vulnerabilities. And the second is the uses for VPN have expanded greatly since the technology first appeared, and it's not uncommon in today's environment to leverage a VPN to provide untrustworthy hosts access to portions of the network. Terminating a VPN directly on your internal network is a dangerous practice, and thus circumstances where a bypass VPN architecture is still a viable solution are limited. Here we see an internally connected VPN. This deploys the VPN so that traffic to the VPN and from the VPN to the internal network is not firewalled in any way. As you can see, between the VPN and the internal network, there is no firewall. An internally connected VPN architecture recognizes that the VPN is vulnerable to attack if placed directly on the internet, so it places the internet-facing VPN connection behind a firewall. This still doesn't address potential security issues associated with untrustworthy VPN connections. Here we see a VPN within a DMZ, protected from the untrustworthy internet by a firewall and then from the internal network by another firewall. This addresses the main shortcomings of the two previous implementations. It features a firewall in front of the VPN to protect it from internet-based attacks, as well as a firewall behind it to protect the internal network. The firewall on the inside can be configured to protect important infrastructure like finance department or research department servers, restrict business partners to only the systems to which they need access, or even limit vendor access to only those systems that they support. The largest drawback to this design is the cost of deploying multiple firewalls for the implementation, but many companies already have DMZs set up on this configuration. The last two slides of this part deal with VPN deployment planning. Here you must plan the physical location of the VPN. Ensure that the location meets power and cooling requirements. Plan your IP addressing scheme, and that's for both external and internal network connections on the VPN, as well as for pools of addresses assigned to clients when they connect to the VPN. Plan firewall rules for permitting VPN access. Configure the VPN server. Set up the IP address pools, assigning IP addresses to the interfaces, establishing your banner message, and disabling split tunneling. It's also a good idea to have the vendor review the configuration before going live. Test the deployment. You may want to create a pilot group to test the deployment. Create an operations manual, user documentation, etc. Develop support processes. Before you develop those support processes, as far as creating the operations manual, you want to state that the rollout plan needs to be communicated to management and affected employees. 11th, you want to install VPN clients for any remote access users. And of course, lastly, you want to train the users. Our next set of slides deal with VPN hosts and trusts, the nature of VPN threats and attacks, vulnerabilities, and so forth with regards to a VPN, and of course how to troubleshoot them. So this concludes part 1.